and today I will discuss about how to solve for the general and standard equation of a circle. In this problem, we are tasked to find the equation of the circle with a center located at 3, 7 and has a radius of 5. So, to solve for the equation, we need to substitute the values h, k, and the radius to the standard equation in order to solve for the general equation. So, we all know that h and k are the coordinates of the center. So, 3 will be the h, 7 will be the k, and r will be 5. So, the standard equation of a circle is the quantity of x minus h squared plus the quantity of y minus k squared is equals to r squared. Substituting the values, it will be the quantity of x minus 3 squared plus the quantity of y minus 5 squared is equals to 5 squared. So the final standard equation of this circle will be the quantity of x minus 3 squared plus y minus 5 squared is equals to 25. And from there, we can solve for the general equation of the circle. First, we're going to expand the binomials quantity x minus 3 squared and quantity y minus 5 squared. So it will be the quantity of x squared minus 6x plus 9 plus the quantity of y squared minus 10y plus 25 is equals to 25. So after that, we're going to combine all the terms in the left hand side, so it will be just 0 on the right hand side. And after that, we're going to combine all the like terms, and the answer will be x squared plus y squared minus 6x minus 10y plus 9 is equals to 0. And that will be the general equation of the circle. In reverse, we are tasked to find the center and radius of the circle with the equation x squared plus y squared plus 6x minus 10y plus 18 is equals to 0. To solve this problem, we need to convert it first to standard equation. So, to convert it into standard equation, we need to combine all the like terms first, and this will be the quantity of x squared plus 6x and y squared minus 10y. So as you can see, we have the missing terms here, which will be later obtained by completing the square. So we could have a perfect binomial and we could factor it into a standard equation. So in completing the square, we will be using the formula c is equals to the quantity of b over 2 squared. So the answer would be the quantity of x squared plus 6x plus 9 plus the quantity of y squared minus 10y plus 25 is equals to negative 18 plus 9 plus 25. So we need to add the 9 and 25 to the right side of the equation to follow the laws of equality. After that, the right side will be equal to 16. So as they are already perfect square binomials, we could factor it into the quantity of x plus 3 squared plus the quantity of y minus 5 squared is equals to 16. And this is the standard equation of the circle. Going back to the standard equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared is equals to r squared, we can easily identify the values needed for this problem, which is h is equals to negative 3, k is equals to 5, and the radius will be the square root of 16, which is 4. The final answer to this problem is the center is negative 3, 5, and the radius is 4.
For the first problem, we need to compute for the standard and general equation of the parabola whose vertex is located at 3, 7 and focus is at 3, 10. Let's start off by figuring out the axis of the parabola. Since the opening nor the axis of parabola is not given, then we have to analyze it. By looking at the given, we can see that the vertex and focus has the same x-coordinate. By referring to the table, this only happens when the parabola is vertical. Therefore, the parabola here is an example of a vertical parabola. Next, let's find out the values of h and k. Given that the vertex is located at 3, 7, then the value of h is 3 and the value of k is 7. Then we need to find for the value of p. In order to solve the value of p, we need to refer to the focus of vertical parabola, and that is h, k plus p. Since the value of k plus p is 10, that gives us the equation k plus p equals 10. Then just substitute the value of k to the equation, which is 7. So this gives us 7 plus p equals 10. Then just transpose 7 to the right side and this becomes negative 7. And just subtract 10 from 7, and that gives us p equals 3. To solve for the standard equation, just substitute the values of h, k, and p to the equation of vertical parabola, which is the quantity of x minus h squared equals 4p times the quantity of y minus k. And that gives us the quantity of x minus 3 squared equals 4 times 3 times the quantity of y minus 7. Then we just need to perform the necessary operation to solve for the standard equation by multiplying 4 and 3. And that gives us the equation, the quantity of x minus 3 squared equals 12 times the quantity of y minus 7. And that is our standard equation. Now, we can finally solve for the general equation. First, we need to expand this squared binomial, which is the quantity of x minus 3 squared. And when we expand this will result in the equation x squared minus 6x plus 9. On the other hand, we need to distribute the constant which is 12 to the quantity of y minus 7, and that gives us 12y minus 84. After that, we just need to move everything to the left hand side, and that becomes x squared minus 6x minus 12y plus 9 plus 84 equals 0. Finally, we just need to perform the necessary operation by adding 9 and 84 and arranging it to the general equation of the vertical parabola. And that gives us x squared minus 6x minus 12y plus 93 equals 0. For the second problem, we need to compute for the properties of the general equation of the parabola, which is y squared minus 4x plus 4y plus 16 equals 0. Let us start by solving for the vertex and the length of the latus rectum. First, we need to combine the like terms by grouping the terms with y variables to the left side and leave a space for the last term. We need to leave a space for the last term because we need it to complete the perfect square trinomial. On the other hand, we need to transpose the term with x variable and constant term on the right side. So the equation will become like this. Y squared plus 4y plus blank equals 4x minus 16. Then, we need to compute for the last term of the perfect square trinomial. In order to do that, we need to divide the constant of the middle term of the perfect square trinomial by 2. And then we need to square it. So it will become like this. So here, the 4 here is the constant of the middle term of the perfect square trinomial. So we need to divide it by 2. So 4 divided by 2 is equals to 2. Then we need to square it. So 2 square is equals to 4. So the 4 here now is the value of the last term. After that, just as we added 4 on the left side, we need to add 4 on the right side also. So the equation now will become like this. So y squared minus 4y plus 4y plus 4 equals 4x minus 16 plus 4. So now we just need to factor the left side and perform the necessary operation on the right side by adding negative 16 and 4. So now the equation will now result like this. So the quantity of y plus 2 squared equals 4x minus 12. Now, we just need to factor the right side also. So, to solve the standard equation. So, the standard equation will be the quantity of y plus 2 squared equals 4 times the quantity of x minus 3. Next, to find out for the vertex, we just need to change the signs of the values of h and k. So the negative 3 here will become 3 as the value of h, and then the positive 2 here will become negative 2 as the value of k. So the vertex now is located at 3, negative 2. Then the latus rectum here is equals to 4 since the value of 4p is 4. Then after that, we need to determine the axis of the parabola based on the general equation and the standard equation, it is in the form of horizontal parabola. Therefore, the axis here is horizontal. Then, since the length of the latus rectum is positive 4, then the opening here is right. After that, we need to solve the value of p. So, in order to do that, we just need to equate 4p to 4. Since 4 is the value of 4p, then we just need to divide it by 4. Then now the value of p here is 1. Then we need to solve for the focus. So we need to consider the focus of the horizontal parabola, which is h plus p, comma k. So using the h plus p, we need to substitute the value of h, which is 3, and the value of p, which is 1, to the h plus p. So it will become 3 plus 1 equals 4. Now the value of h plus p will become 4 here. Then the value of k, we just need to substitute the value of k here, which is 2, which is negative 2 here. So the focus now is 4, negative 2. Then we just need to find the directrix by referring to the directrix of the horizontal parabola, which is x equals h minus p. So we just need to substitute the value of h, which is 3, and the value of p, which is 1, to the formula. So it will become x equals 3, negative 1. So we just need to perform the necessary operation. So 3 minus 1 is equals to 2. So x equals 2. So 2 is the directrix.
Good day, I am going to discuss one of the conic section, which is ellipse. In solving for the standard and general equation of ellipse, we must consider the given properties. Here is an example. You have the center of the ellipse, which is located at 4, negative 6, one of the vertices, which is located at 9, negative 6, and one of the co-vertices, which is located at 4, negative 8. We must identify the axis first. As you may have noticed, the y-coordinates of the center and one of the vertices are the same, which is negative 6, while the x-coordinates are different. This basically means that it is a horizontal ellipse. Now that we know that it is a horizontal ellipse, we are going to solve for the values of h, k, a, and b. Since the center is already given, we now have the values of h and k. H is equals to 4 and k is equals to negative 6. For the values of a and b, we must refer to the table. For a, we could consider the major axis and the vertex. However, the major axis is not given, so we are going to use the vertex. It says here that the x-coordinate of vertex should be h plus or minus a, and according to the given, it is equals to 9. So h plus or minus a is equals to 9. Now we can choose arbitrarily between plus or minus. So I am going to choose plus because regardless of sign, it only tells us the direction. So we have h plus a equals to 9. Since we already have the value of h, which is 4, we can substitute it, so it would be 4 plus a equals to 9. Now solving for a, we have a equals to 5. Because we moved the 4 from the left-hand side to the right-hand side, which made it into negative 4. So 9 minus 4 is equals to 5. Hence, a is equals to 5. For b, we could consider the minor axis or the co-vertices. Since one of the co-vertices is given, we can consider it. It says here that the y-coordinate is k plus or minus b, and based on the given, the y-coordinate is negative 8. So we have k plus or minus b equals negative 8. Again, we can choose arbitrarily between plus or minus. So I am going to choose plus because regardless of sign, it only tells us the direction. So we have k plus b equals negative 8. Since we already have the value of k, which is negative 6, we are going to substitute it. So it would be negative 6 plus b equals negative 8. Solving for b, we have b equals negative 2 because we moved the negative 6 from the left-hand side to the right-hand side, which made it into positive 6. So it would be negative 8 plus 6 equals to negative 2. Since b is just a distance, we can disregard the negative sign. So b is equals to 2. So we have h is equals to 4, k is equals to negative 6, a is equals to 5, and b is equals to 2. Now we are going to substitute the values to the standard equation of ellipse, which is x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals to 1. Then it would become x minus 4 quantity squared all over 5 squared plus y minus negative 6 quantity squared all over 2 squared equals to 1. And we are going to perform the necessary operations. So we have x minus 4 quantity squared all over 25 plus y plus 6 quantity squared all over 4 equals to 1. Now, in solving for the general equation, it is not in rational form. What we have is a one-line function. So what we need to do is to eliminate the denominators, and we could do it by multiplying both hand side of the equation with the LCD. So the LCD for this is 100. So multiply both hand side with 100. We now have 4 times x minus 4 quantity squared plus 25 times y plus 6 quantity squared equals to 100. After that, we can expand the binomial. Then we have 4 times x squared minus 8x plus 16 plus 25 times y squared plus 12y plus 36 equals to 100. Next, we can simply distribute 4 and 25 to the trinomial, which gives us 4x squared minus 32x plus 64 plus 25y squared plus 300y plus 900 equals to 100. Lastly, we move everything to the left-hand side, combine like terms, and arrange them. So we have 4x squared plus 25y squared minus 32x plus 300y, and then we have 900 plus 64, which is 964, and then since we move 100 to the left-hand side, it becomes negative 100. So 964 minus 100 is 864. So plus 864 equals 0. So our general equation is 4x squared plus 25y squared minus 32x plus 300y plus 864 equals 0. And that's for the standard and general equation of ellipse. Now we are going to solve for the properties of an ellipse. We have a given here, 4x squared plus 25y squared minus 32x plus 300y plus 864 equals to 0. So this is a general equation and we have to make this into a standard equation. So what we would do first is we are going to group all terms with the same variables and move the constant term from the left-hand side to the right-hand side. So we have 4x squared minus 32x plus blank plus 25y squared plus 300y plus blank equals to negative 864. Since x squared and y squared have coefficients, we must factor it out. So we now have 4 times x squared minus 8x plus blank plus 25 times y squared plus 12y plus blank equals to negative 864. Now, we can complete the square by dividing the coefficient of the middle term by 2, then squaring it. So the first middle term is negative 8x, so its coefficient is negative 8. So we divide it by 2, we have negative 4. And then we square it, we have positive 16. And then the second middle term is 12y. So we are going to divide it by 2, we have 6. And then we are going to square it, we have 36. So we have 4 times x squared minus 8x plus 16 plus 25 times y squared plus 12y plus 36 equals to negative 864. Then we're going to follow laws of equality. So what we add in the left-hand side should also be done in the right-hand side. So we're going to add 16 and 36, but we must multiply them to the coefficient first. So we have 16 times 4, which is equals to 64, and then 36 times 25, which is equals to 900. So we have negative 864 plus 64 plus 900. We can then factor them out into perfect squares and perform necessary operations. So we now have 4 times x minus 4 quantity squared plus 25 times y plus 6 quantity squared equals to 100. A standard equation of ellipse should be equal to 1. So we divide 100 by itself. And again, laws of equality. So we also divide the left-hand side with 100. So it would become x minus 4 quantity squared all over 25 plus y plus 6 quantity squared all over 4 equals to 1. Now we have the standard equation of the ellipse. We can now solve for its properties. Its axis is horizontal because A is bigger than B. So 25 is A squared, which is bigger than 4, which is B squared. For the center, we can see it with x and y, which is negative 4 and positive 6. So we are just going to change its sign. So center is located at 4, negative 6. For foci, the x-coordinate should be h plus c and h minus c. So we must consider c. However, for c, we must consider a and b. So we have 25, which is a squared. So we're going to get the square root of 25, and it would be 5. So a is equals to 5. We also have the b squared. So we are going to square root 4. So it would be 2. So b is equals to 2. So for c, we have c squared equals a squared minus b squared. So that would be 25, which is a squared, minus 4, which is b squared, which would then equal to 21. So c is square root of 21. Next is for the vertex. We just need to add and subtract a to the x-coordinate since we have horizontal ellipse. So we have 9, negative 6 and negative 1, negative 6. Next, we can now consider co-vertex. We need to add and subtract b since co-vertex is always against the axis, which is in this case horizontal. We are going to consider the y-coordinate instead. So we have 4, comma, negative 4 and 4, comma, negative 8. For major axis, written here as MJ, we just multiply A to 2, so 5 times 2 is equals to 10. So major axis is equals to 10. For minor axis, written here as MN, we multiply B to 2, so 2 times 2 is equals to 4. So minor axis is equals to 4. So that's all for the properties of this horizontal ellipse. Thank you.
Good day everyone, my name is Lloyd Layese, and for today we will discuss the conic section hyperbola. So for the first example, find the standard and general equation of a hyperbola given that the center is -1, 3, the transverse axis is 16, the conjugate axis is 8, and it is horizontal. So given that the axis is horizontal, we will use the horizontal hyperbola table. And there, we can locate the center or the value of hk. Since the center is already given, the h value is -1 and the k value is 3. And now, we will have to find the value of a and b. So for finding the value of a, we will use the transverse axis. So 2a is equals to transverse axis. The value of the transverse axis is 16. So 2a is equals to 16, divide both sides by 2, a is equals to 8. So the a value is 8. And now we will proceed to finding the b. So in order to find b, we will use the conjugate axis. 2b is equals to conjugate axis, where the length of the conjugate axis is 8. 2b is equals to 8, and dividing both sides by 2, b is equals to 4. So the b value will become 4. Now we have the values of h, k, a, and b. We can now proceed to substituting it in its standard equation. So I did not put the negative sign at first because we will have to identify first if the hyperbola is vertical or horizontal. Since it is horizontal, we will use -b. And now we will substitute it. So first, we will substitute h, k, then a, then b, then perform the operations. 64 and 16 will be now the new denominators, and now we have this. So this is the standard equation of the hyperbola. Quantity x plus 1 squared all over 64 minus the quantity y minus 3 squared all over 16 is equals to 1. So to find its general equation, we will have to multiply both sides by the LCD, which is 64. So in multiplying that, it will result to this. So this the quantity x plus 1 squared minus 4 times the quantity y minus 3 squared is equals to 64. Now we have to expand the perfect squares. And then we will multiply -4 to the y terms, or the y group. It will result to this. And the new x squared plus 2x plus 1 minus 4y plus 24y minus 36 equals 64. And then we will transpose the constant 64 to the left side to make the right side 0. So when performing that operation, -36 plus -64 will become -99. So the result will become like this. We will need to arrange the terms. So the general equation is x squared minus 4y squared plus 2x plus 24y minus 99 equals 0. So the answer to this problem, or question 1, is these two. So the standard equation is quantity x plus 1 squared all over 64 minus quantity y minus 3 squared all over 16 is equals to 1. And the general equation is x squared minus 4y squared plus 2x plus 24y minus 99 equals 0. Now let us proceed to the next problem. So in the next problem, we have find the properties of a hyperbola with an equation of x squared minus 4y squared plus 2x plus 24y minus 99 equals 0, which is the general equation of the previous example. So we will just have to reverse the process. So in order to find that, we will group the like terms or the similar terms. We will group x and y and then isolate the constant to the right side. And given that, we will now factor out the negative 4 or the GCF of the y terms. There, it will become quantity x squared plus 2y minus 4 times the quantity y squared minus 6y equals 99. And then we will have to complete the square. So in completing the square, we will find the value b over 2 squared. So the b over 2 squared of the x group is 1, and the b over 2 squared of the y group is 9. Multiplying it, we will add 1 and 9 multiplied by negative 4 to the right side to make it even. So now it will become x plus 1 squared minus 4 times the quantity y minus 3 squared equals 100 minus 36, which is 64. So we will have to divide 64 on both sides to make the right or the constant on the right 1. So there. This will become the answer, which is the standard equation. Quantity x plus 1 squared all over 64 minus the quantity y minus 3 squared all over 16 is equals to 1. Now, we will use this equation to find the h, k, a, and b values. So, given that equation, we can say that the h is negative 1, the k is 3, the a, we will find it. The a squared is equals to 64. The a, to find it, we will have to square both sides or find the square root of both sides. A is equals to 8. The value of a is 8, and the value of b, the square root of 16, which is b, is equals to 4. So finding this tree, there, we already have these values except for the C1, so we will have to find the C so we can continue and finding the other properties. So to find C, we need to use the equation of the horizontal hyperbola because it is stated that the b is the negative 1. So there. Finding the C, we have to square the 8 or a and the b, which is 64 plus 16. C squared is equals to 80, square root of the both sides, and it will become 4 square root of 5. So the C value is 4 square root of 5. So now let's find the properties. So analyzing the equation, the y term has the negative 1, so it's already horizontal. So the axis is horizontal because of negative b. And the center is negative 1, 3 because the value of h is negative 1 and the value of k is 3. Now, the focus, to find it, we have to use the h value and the c value and also the k. So the first focus is negative 1 plus square root of plus 4 square root of 5, 3. And that's it. And the second focus is negative 1 minus 4 square root of 5, 3. So these are the two focus. So for the vertex, we will have to find it by using the h, a, and k values. So for the first vertex, we will use h, negative 1 plus 8, which is the value of a, and k, which is 3. So computing that, we will have 7, 3. And the second vertex, we will subtract h. We will subtract a from h. So it will become negative 1 minus 8, 3. It will become negative 9, 3. So these are the two vertex. So for the co-vertex, we'll have to use the value of h, k, and b. So this is the co-vertex 1, negative 1, 3 plus 4. So solving that, negative 1, 7. So for the second co-vertex, we will have to subtract k and b. So negative 1, 3 minus 4, it will become negative 1, negative 1. So these are the two co-vertex. So now, for the transverse axis 2a, we will just multiply a by 2. So 2 times 8 is 16. So the transverse axis is 16. And for the conjugate axis 2b, multiply b by 2. 2 times 4, it is 8. So the conjugate axis is 8. So these are the properties of the hyperbola with an equation of x squared minus 4y squared plus 2x plus 24y minus 99 equals 0. That's all. Thank you.